Hello, everyone. Good morning. From whatever part of the world you are welcome to Omifu Technologies and Unicorn Group of Companies. Today we'll be discussing how multimodal AI works, which is an aid to generalist autonomy. So let me introduce myself. My name is Dagwe Nikorege. I'm a data analyst and scientist, machine learning engineer, as well as Unicorn Group of Companies. I'm a big generative AI enthusiast, and by training, I'm a chemical engineer. So we'll be discussing a lot of questions, and let's go right into it, to this technical session. Okay, so I'm starting with an engaging question. Remember, our topic talks about multimodal AI. And this question is, are humans the only species that could hear, speak, see, and feel? That's the question, and I'm looking forward to see feedback on the chat. Are humans the only living species that could hear, that could speak, and could feel? Well, of course, we have variety of living things, ranging from animals to plants and all, and of course, human beings. But are humans peculiarly the ones that can hear, speak, and feel, have emotions and all? So we'll find the answer to that in the various other slides of this session. Let's move to the next slide. So we'll start by defining what multimodal chatbots and AI is. So this is basically a new approach where we have artificial intelligence interacting with the external world. Or whatever other tasks you ask ChatGPT for. We're familiar with uploading our pictures on Gemini, on GPT, and asking it, okay, edit this picture for me, change the background, and things like that. We're familiar with all of that, right? So what about having an AI, right, that you can communicate with text, with audio, with images, and that depict the human feeling? So that's where the whole multimodal AI and chatbot comes into play. So here you have the large language model, which performs the reasoning. You have the vision that gives it perception, understanding. You have the speech to text that does the listening, and the text to speech, TTS, that does the speaking. So let's move to the next slide, and please stay with me while on a journey here. So the next slide now talks about the data, right? So as powerful as AI is, it always starts from somewhere, and that's somewhere usually what data. So we are now talking about the multimodal data, right? And so this is defined, as you can see in the first part of the slide, talks about a form or a mode that data can be, the same data can be written, spoken, communicated, or even be in an image. So let me use an instance of a dog, for instance. So let's say a dog barking. That's the whole concept, right? A dog that is barking. And so how do you write that? You can write them. I see a dog barking. Then the spoken part will now be, for instance, hearing the sound of the dog. Then the image can be just a pictorial depiction of that kind of thing. So that's what the whole multimodal data, that's what it signifies here. Then moving on to the human-centric communication. As human beings, AI is typically depicting how human beings communicate, right? So human beings, we don't just depend on speaking. If, for instance, you can see the slide displayed here, you can as well as hear me. You can see my gestures when I smile, when I'm serious, and things like that. All of those multimodal data you can pick from just observing this whole technical session. And let's move to real world tasks involving multiple modalities. So we have activities such as video analysis, mood determination from either voice or face. These are real world tasks that involve multimodal data and AI as the case may be. So this allows the chatbot to interact with people using AI to handle data from multiple sources. So combining these modalities enables AI to make a more well-rounded decision. This is so critical. And this improves the performance of your AI, whether you are, let's move to the next slide, whether you are doing a medical check, right? Or you are doing, you are a teacher, right? And you just need assistance, maybe assistance to mark your script, things like that. All of this multimodal data and AI, right, play a role in helping our day-to-day life easier, better, sweeter. Yes. So whether it's gadget repair, whether it's customer support, all of this, the ability of the AI to speak, to hear, to respond, and then to understand images and all play an important role in having having your task performed optimally. All right, I hope you're following through on this. This is very interesting. So let's move on to the next slide. So the next slide now talks about it tells us about the various multimodal chatbots we have. We have the Gemini 1.5, we have GPT 5, we have Quen 2.5, we have the seamless M40, and of course our very own Omefe.ai, right? So once you're on Omefe.ai, we are your number one stop to get the best chatbots, whether it's for your medical scenarios, like you saw in the previous slides. We have agents, we have APIs that can both interact with your patients, assist the doctors as well, to make the whole medical field seamless. Is it in education? We are here for you. Omefe is here for you. Various as your use case is, we are here for you to design chatbots that have this multimodal capabilities, right? And just make your work seamless. So let's move on to the next slide. And now we are now going into a deeper dive where we are now talking about multimodal systems, right? The whole architecture. So I've spoken a lot about it, and so I'm sure someone is asking, how does this work? How can AI hear, speak, and understand images? How does this work? So this picture depicts the architecture of the multimodal system. You can see the transformer model. You can see the cross attention mechanism. You can see the co-embedding techniques, and of course the multi-level fusion. So let's move to the next slide. And this slide is quite wordy, but follow through. I'm sure you understand when you follow through. All right, so we have this starting with the first part of the architecture, which talks about the transformer model. So this is based on the attention mechanism. I'm sure I have a lot of tech enthusiasts here that must have heard of the paper, Attention is All You Need. It's not new to us. So, but for the newbies and for some of us, I would just need a reminder. I'll have a quick recap here on the whole transformer models. So based on the attention mechanism, this enables the AI focus on relevant part of the input, right? So it uses the self-attention to weigh relationships between tokens, between your text, between your images. It weighs the relationship, the importance. For instance, a dog barking, like when you have a text, right, and you can see dog and you can see bark, those words are well related. So those ones will have higher weight, better relationship. So what are the key advantages of this transformer model? So it enables effective learning from large and diverse data, right? And it now forms a base, like the best platform for this whole multimodal models we're talking about right now. So let's talk about the contrast, and it focuses mainly on the intermodal relationship. So it focuses more on, let's say, text alone, images alone, And we already said that it's okay. We are now saying that it forms the basis for the multimodal models and cross attention, which is the next architectural layer we'll now be talking about. So use cases here. We always like to give examples so that it's not all talk, or we have some examples. So we have the vision transformers. This is for image, or we have whisper for speech recognition. Okay, so let's go to the cross attention mechanism. Remember what we're discussing about here is what the whole architecture of the multimodal systems, right? So we're talking about the next layer of the architecture, which talks about the cross attention mechanism. So this enables interaction between multiple modalities, for instance, text and image. And I always refer to my dog backend scenario. Let's move to the next point. So one modality, for instance, text, attends to another, the image, and this align to interpret the context. So what's the key advantage? So it strengthens contextual understanding of cross modalities for tasks like image captioning or video Q&A. So the contrast is contrasting to transformer. It extends the transformer. We know we already said the transformer is intra, so it extends the transformer, and now you have multiple modalities on this this particular layer of the architecture. And we have the next architectural layer we're now discussing now is the co-embedding techniques, where you have multiple modalities now in shared latex space. So this one will now map your visual, your audios, and your text in a unified vector or space for joint processing. All right, so let's move to the next slide. Yes, this should
Cap, here's the important context I want you to have in mind. The goal of the model that you and I are studying is what word comes next. The input text is broken up into little pieces that we call tokens, and these are very often words or pieces of words. But just to make the examples in this video easier for you and me to think about, let's simplify by pretending that tokens are always just words. The first step in a transformer is to associate each token with a high-dimensional vector, what we call its embedding. Now, the most important idea I want you to have in mind is how directions in this high-dimensional space of all possible embeddings can correspond with semantic meaning. In the last chapter, we saw an example for how...
All right. So that depicts the whole tokenization. And although that refers specifically to text, we can then apply it to images, to audios, and the like. So let's have a deeper dive. Now we're talking about deep learning fusion, integrating modalities at different levels. So now that we have spoken about different types of data, right? I'm sure someone is now wondering, like, so how can I fuse these various forms of data? How and when, right? So this is what we're going to be explaining on this slide. So the deep learning fusion refers to combining multiple data modalities such as text, audio, and images within a single model to improve understanding, context awareness, and decision making, right? So so we now have fusion can occur at different stages of the model processing. It can occur as early fusion, it can also occur as late fusion, and it can be a hybrid, right? So the early fusion merges the raw features from each modality at the input stage to capture low-level correlations, right? So this may be less effective when the modalities are misaligned or vary in scale and structure, right? So let's move on to the late fusion. This one processes the modalities, and I'm sure you remember when we talk about modalities, we're referring to the various forms of what data, whether it's text, whether it's speech, whether it's video, and so this processes each modality independently and combines the output at the final stage. This design supports flexibility across modalities at different lengths or structures, but it may weaken the contextual coherence. That may be a disadvantage of the late fusion. And of course, we have the hybrid fusion. So talking about the hybrid, this integrates modalities at multiple stages of the model pipeline. balancing flexibility within the deeper semantic alignment, often leading to improved accuracy. So the hybrid fusion is like a combo of the two we discussed above, applying the right fusion needed per time for your model, for your chatbot. So let's continue. Let's move to the next slide. And yes, we're talking more and on on building your multimodal chatbot. And as you know, this modality was spoken about vary. Images vary from text, like obviously, and text vary from audio. So definitely challenges are expected. So how do you handle these challenges? And one of the main challenges, right, data collection. This is so critical. Data collection. How do you collect this data? How do you ensure it's well labeled, well synchronized, well annotated, well aligned, the text, the audio, and the visual? How do you ensure that they all synchronize such that your model is seamless, error-free? The models that we produce for you at Umifield, like I said earlier, are seamless, error-free. And I'm running you through the journey of how we do this. Let's move to the next slide, and you'll see it explained in detail. So we have the alignment strategies, right? And I'll just move straight to the examples so as to give us a clearer understanding. So we have the temporal, we have the spatial, and we have the thematic. So this is the example you here is matching subtitles to the exact moment when the speech occurs in a video. That's one method, right? And another method is aligning spoken commands with the location on the interface or image. This talks about your visuals and location and all. And semantic is linking the word, for instance, dog in the text to the corresponding image or sound. So let's move on to the self-supervised learning. So how does self-supervised learning work? This makes the whole gathering of your data seamless, better, and things like that. So how does the self-supervised learning work? So you use the self-supervised learning for automatic label generation, right? So you don't have to manually go ahead to be labeling your data one by one. The whole self-supervised learning enables the model to learn by itself, and then it can give them accurate labels to a large chunk of data. So the example here is Clip that learns to connect image caption pairs without explicitly labeling by contrasting, matching, or non-matching pairs. Right, so we're discussing ways to make this your multimodal chatbot easier, right? I was speaking about various alignment strategies, and now we're talking about self-supervised learning, and of course, we're talking now about large-scale pre-trained models. So important. Although the core challenge here is computational power, data cost, training, and all, its advantages are also well spelled out here. It saves time and resources while enhancing performance and generalization. So using various pre-trained models for your multimodal chatbot, multimodal AI would help reduce the challenges we spoke about in the previous slide. And here is an example here for us to all see. So let's move to the next slide. And I just emphasize that effective multimodal AI relies on proper alignment of data, self-supervised learning to reduce labeling efforts, and large-scale pre-trained models to accelerate development while preserving performance. All right. This has been quite wordy. In the next few slides, you will have a video depicting the AI, multimodal AI, and the generalist autonomy. So in last two technical sessions, we had a very interesting session, and that session was talking about generalist autonomy, right? And the whole session was talking about robots, and I'm sure we have heard of the popular Omefi, that's our humanoid robot, right? And if you haven't watched it, please go ahead and view it. So we talked about how the robot why the robot need body. Like when you already have your AI, why the robot need body? So this whole multimodal AI now relates goes back to the whole generalist autonomy and shows the relationship and its importance, the role it plays to make this a reality. So let's have a deep dive into this. So like we discussed earlier, multimodal AI provides perception and communicative intelligence, both the ability to speak, to hear, and to see and reason. And this forms the foundation of the generalist autonomy. And we'll be seeing a video on that in our next slide, which will be our last slide, where systems act independently across tasks and environments. So we have the multimodal AI. It integrates vision, the audio, and the language for human perception. And this enables machine to understand and generate contextual relevant responses. And we have various models here. And of course, I'll make reference to our Omixi. Yeah. So how does this now relate to the autonomy we discussed about? So vision models observe and analyze, right? So that's where the whole autonomy is coming to play. I mean, science is going broad, science is going very fast, and the discoveries are quite commendable. But how long can humans stay in the lab to do this experiment, right? How long? And how many humans do we have that can do this experiment, check out this research, these findings accurately? How patient can they be? So we're not saying we want to replace humans here, but we're saying we want to collaborate with humans, right? So that's where the whole autonomy comes in, where you have a machine that can observe and analyze and lab experiments and things, where you have an autonomy that speech, where speech models are applied for interaction and communication with humans, which is so incredible. Where you have language models that can now reason, right, go in depth, and do some hypotheses and even generate reports. And together they create a sensor motor grounding, like perception to action. So this will be my last read for today before we go into our last video for today as well. That the multimodal AI gives systems the senses and understanding they need, agentic reason, and robots give them the autonomy to act together, and they're able to achieve this true intelligent autonomy. All right, so let's have the last video. I'm just depicting the whole generalist autonomy. Um,
Right there. How's this? Perfect.
Robot interacting, performing tasks. I mean, I provided the link to the previous technical sessions here that you can view and learn more about this whole generalist autonomy. All right, thank you so much. These are my references, and a big thank you to the team and everyone that made this a reality. Thank you so much for joining us on this session. And we hope to see more of you on our channels, liking our videos, reposting and sharing. And I'm sure you learned one or two things, and